Hi, I'm Rob, and I'd like to welcome you to this video on implementing an AI workflow with the OpenAI API. In the last video in the playlist, Getting Started with the OpenAI API, we covered the basics of calling OpenAI models directly. In this video, we'll build on that by implementing a structured multi-step AI workflow with iteration, validation, retries, guardrail-driven regeneration, and fault tolerance. Now, rather than jumping right into the code, I want to show the app first so you can see exactly what we're building. Then we'll walk through the implementation. However, before we get started, I want to mention that if you're not familiar with using the OpenAI API and haven't yet watched the prior video in the playlist, you may want to do that first as it covers getting an OpenAI API key, which you'll need to follow along here. Okay, with that out of the way, let's get started with the demo. Now, this project is a Python CLI app that generates a full set of YouTube content artifacts, a synopsis, title, video description, full story script, and a thumbnail image, all powered by the OpenAI API. And to launch the app, we'll follow the steps in the quick start section of the README. I've obviously already cloned the repo, and I'm in the 9 AI workflows folder in a terminal. I've also already saved the .env.example file as a .env, and I've added my OpenAI API key, which you'll also need to do. Now I'll run UV-sync since I'm using the UV package manager, then launch the app. And now we're prompted for a video subject, genre, age group, and video length, all of which are required, and the app will reprompt you if you leave any blank. Now, the app calls OpenAI's Responses Create API to generate a story synopsis using the base model, which is GPT-5 Nano. I can approve the synopsis or decline it to have the model regenerate one, but I'll go ahead and approve. Now the model is generating the title, which I'll decline, so we can see it regenerate a new one. Here I'll go ahead and accept, and the app will move on to generating the description, which I'll go ahead and accept. And now the app moves on to generating the story content using GPT-4o Mini. And there can be up to 2 draft attempts for this, because after the first draft is generated, the app will pass the story text to GPT-5 Nano to do a guardrails check for inappropriate content. If the guardrails check fails, the model will regenerate the text again. Here we see the guardrails check passed, so now the app moves on to creating the thumbnail image by calling the OpenAI Images Generate API. You can adjust the parameters you pass to the API to change the size and quality of the image. And when that is complete, a JSON object with the story content is returned, and assets are created in the output folder, which we see here. Okay, now that you've seen the app in action, let's discuss the workflow. What I want you to notice here is that this is not just a one-shot prompt script. It's organized around production-minded patterns with typed inputs and outputs with Pydantic, modular components for orchestration and API calls, retries for transient failures, guardrail-based validation, and output packaging. The goal is to move from I can call a model, which we did in the prior video, to I can run a repeatable, reliable workflow. And this pipeline is intentionally broken into clear stages. First, we generate a synopsis, then a title, then a description, and each of those uses an approval loop so we can accept or regenerate, as we saw in the demo. Next, we generate the full story and run a structured guardrails check, and if the check fails, the workflow regenerates the story, including the failure reason as feedback to the model up to the configured retry limit. And only after the story passes the guardrails do we generate the thumbnail. Then the workflow persists the final artifacts to disk and returns a structured JSON result, which makes it easy to integrate this flow into other tools. Now, before we get into the Python code, let's look at the environment variables, because this is where the workflow becomes configurable without having to make application code changes. Of course, we have the OpenAI API key, and we specify an output directory for the story artifacts. Then we move into the models. The base model variable controls the default model path, and step-specific overrides let you tune quality and cost for each stage. Here, by default, the model synopsis inherits from the base model, and the model title and model description inherit from the model synopsis. So all these models are using GPT-5 Nano. The model story is set to GPT-4o Mini, but if this is left blank in the .env file, it will inherit from the base model. And the model thumbnail image uses GPT Image 1 Mini. There's additional information in the model usage guide markdown file if you'd like to take a look. But now we're going to jump into the main application code. However, before we do that, I want to mention that we're going to walk through existing code, not write it from scratch, as this app is meant to be a bridge between the prior video in the playlist, where we called OpenAI APIs directly, to the next app, where we'll build Script Sprout, our prompt to YouTube ready story content app for creators, as a full web application which fronts a similar workflow we'll walk through in this video. So let's jump into the Python code and get started. And we'll start with the init Python file in the source folder. This exposes the package's public interface, the app config, run workflow, story parameters, and key exceptions. It also surfaces a version, so the package can be embedded by other Python code with a stable API surface. The config file is the runtime configuration contract for the app. Note that app_config is a class which inherits from the Pydantic base model. And from env is annotated as a class method, which means this method can be called directly on the class. And CLS is the class itself. The method returns the class with the environment variable set from the values in the .env file. This gives us predictable behavior and prevents hidden configuration drift during a run. The schema file defines strongly typed app contracts for story parameters for user input, approved pipeline bundle for author approved synopsis, title, and description passed into the full story generator so the script stays aligned with what was already accepted, guardrails check result for structured pass-fail validation, and workflow JSON result for the final output payload. This is important because it keeps model outputs and workflow boundaries explicit and testable. Moving into the prompts file, this centralizes prompt construction and guardrails text. Instead of scattered prompt strings, we have composable builders for synopsis, title, description, full story prompt, as well as guardrails and the check prompt. And the thumbnail prompt with strict no text in image requirements. The API module wraps OpenAI calls behind a small, reliable interface. Its key functionality includes with retry, which handles transient errors with exponential backoff, generate text, which is the standard responses create wrapper, guardrail check, which uses structured parsing for typed validation output, generate YouTube thumbnail, which calls image generation, and thumbnail has visible text, which returns a vision-based text detector that classifies output as text present or no text. And finally, this has the create client method, which returns an instance of an OpenAI client. So this file is where provider-specific details are isolated from the orchestration logic. The story module handles one of the core reliability behaviors. It generates a story, runs guardrail checks, and regenerates with failure feedback if needed. The loop is bound by the max story generation variable and each failed attempt feeds its failure reason into the next draft prompt. If all attempts fail, it raises the guardrails violation and stops clearly. This is the guardrail-driven regeneration pattern in the code. And the workflow Python file is the orchestrator for the entire pipeline. It provides a synopsis approval loop, title approval loop, description, story generation, guardrail retries, and thumbnail generation. The run workflow method starts by setting an instructions variable equal to calling the build instructions method, passing the genre. And we see build instructions returns a formatted string, which injects the results of calling the getModelRole method, passing the genre, which returns the prompt for the model role. It then injects the results of calling the getGuardrails method, which builds a prompt ensuring that no inappropriate content is generated. This is then returned back to run workflow, which then sets the value of synopsis by calling the approval loop method, defined above, which will generate text in a loop until the approve function returns true. So while in the loop, the text property is sent by calling the generate text method. In the API, which calls the responses create API on the OpenAI client. This is then returned back to the workflow, where the text is passed into the approve function, which is passed in as a parameter, which was also passed into the run workflow method, which is defined above. After the synopsis is generated, the title is created by passing the synopsis to the build title prompt method in the prompts file. After the title is created, we'll get the description by passing the synopsis and title to the build description prompt. Then we'll use the synopsis, title, and description to create an instance of the approved pipeline bundle class, and then pass that with the OpenAI client configuration, instructions, and parameters to generate story with guardrails. Then we'll build the thumbnail prompt to generate the thumbnail and call thumbnail has visible text to validate that there's no text in the thumbnail. If there is, we'll go back up and regenerate it again until either there's no text or we've hit the maximum number of attempts. Then we'll call the write run bundle method, passing the output directory path, the title, description, story, and path to the thumbnail, ultimately persisting these assets and returning the workflow result in JSON. And the last file we'll look at is the CLI Python file, which only handles terminal interactions. It has the main processing method in the app, and it prompts for user input, approvals, and regeneration decisions, as well as error handling and returning the final JSON. But it delegates the real application work to the run workflow function. So CLI concerns stay separate from generation and orchestration. So that was a quick walkthrough of this app, which moved us from the last video where we called the OpenAI APIs directly to an AI workflow with multiple coordinated steps, typed data, human approval where it matters, automatic retries, and guardrail checks before we ship artifacts using multiple models. This sets us up for the next video where we'll build Script Sprout, our prompt to YouTube ready story content app for creators, as a full web application with user accounts, a database, media in the browser, and admin tooling on top. I hope to see you there.